In this artificial intelligence class, we will see the image formation, that is the next topic of perception from 4th unit. Under this class, we will see the image without lens, that is pinhole camera, lens system, and scaled orthographic projection, light and shading, and color. So this is somewhat interesting when compared to all other topic in artificial intelligence. Let us see all those topics one by one. Image formation. Here imaging is the technique which is used to get the appearance of object on various perception. Okay, the object is here. Okay, so the same object will be looks different in front view and it looks different in top view, and the same object will give different look on side view. Okay, so this is called as imaging. For example, we can take a picture of a straight railway track. Okay, from the image we can suggest that the railway tracks will converge and meet at one point, isn't it? But originally, see, this is the railway track, this is the original one, and this is the image. Okay, but originally the track never meet at any point. Okay, but by our image, the track will meet at some one point, we can suggest by using our image. Okay, let us take another example. We can hold your hand in front of our eyes so that we can hide out the moon. Okay, but the hand size is very small when compared to moon size, right? So by using our hand we can easily hide the moon. This is the second example. And third one, the same hand, if you move the hand front and back, so that you can see the hand size is increased or shrinked out. Okay, but originally the size never get changed, size of our hand is not changed. So because of the movement or because of the distance between the eye and our hand, the eye size, that is the hand size, will get changed. Okay, so the models of these effects are essential for recognition and reconstruction. Images without lens, that is the pinhole camera. Here the image sensor uses the pinhole camera. The pinhole camera means without any lens on the camera, okay, which gathered the light scattered from the object in a scene, right, and create a two-dimensional image. That is, by using this pinhole camera we can take a photo of current scenario, right. Here in cameras the image is formed in image plan. The plan may be the film roll or the pixels. Okay, the pixels means rectangular grid of few millions of photosensitive pixels, and that is because of the CMOS or CCD. CMOS means complementary metal oxide semiconductor or charge coupled device. Okay, so by using these devices we can take the current image of current scenario. Okay, here the image sensor reports the weighted average of intensity of light arriving at the sensor. Okay, so based on the light scattered on the object, the camera will take the image of current scenario. The very simplest way to form the focused image is to view the stationary object in the pinhole camera, which consists of pinhole opening in the front of the box and the image plan at the back of the box. Okay, so this is the pinhole. See, this is the pinhole. From this pinhole the light of this object will be passed through, and the back side of the pinhole plane the image will be appeared. Okay, in the back side of the box the image will get appeared. Okay, the photons in the scenes must pass through the pinhole. Okay, the light of this object will pass through this pinhole, and based on the size, if the size is small, then we can easily focus that image in the camera. Let us see the working of pinhole camera. This is the image for pinhole camera. This is the image of pinhole camera. Here each light sensitive element in the image plane. Okay, so the image is appeared here. The light of this image will pass through this pinhole of this camera and it will be captured at back side of the image. Okay, image plan is captured at the back side of this box. Here the projection means the large and distant object. So the large size, but it is placed at the distant this object, and the small object which is placed nearby object. So this both size looks similar here. Okay, so this is called as projection. Okay, here the image in the projected the image is projected upside down. See here, the image is projected upside down this way. The drawbacks of pinhole camera. Here we need a pinhole to keep the image in focus. Okay, very small hole. So by using the small hole only we have to capture the image on the surrounding, or that is environment. But the smaller pinhole, very few photons get through. Okay, so here very few photons will get through, hence the image will be dark. Okay, suppose if we open this pinhole camera for a long time, okay, to gather more photons, but the image will get blurred. Okay, the object in the scenes that move appear a blurred image. This is the drawback of pinhole camera. The lens system. To overcome the drawback of pinhole camera, the modern cameras are using lens system. Here the lens system is used to gather sufficient light while keeping the image in focus. Okay, this is the lens here and the object is here. So by using lens we can easily focus this particular object. Okay, here the large opening is covered. The lens is having large opening so that more light intensity will be gone through the lens. Okay, so that will easily focus from nearby object. And the lens is also having some limitations, that is depth of field limitation. That means by using lens we can cover only a portion of environment. Okay, and all the other scenes are out of focus. Okay, we cannot focus all the other scenes in the environment, right? So if you want to cover all those things, we have to adjust the camera, that is front and back. By moving or by adjusting the camera we can focus the other areas of the environment also. The lens system that will collect the light of the scene. See, lens system is here, that will collect the light of a particular object. Okay, and that will focus in the image plane at a single point, at a particular point otherwise. Okay, here focusing means, so based on the distance of this lens, that will cover the size of, that is a portion of the object. By adjusting this lens we can easily cover the required object in the environment. Okay, so the elements of lens system moves to change the focal plane. So based on adjusting this lens we can cover only the required portion of the environment. Scaled orthographic projection. For this let us take these two pictures. Here the leopard is close to the camera and here the leopard is away from the camera. Okay, here the spot in this leopard and the spot in this leopard are different. Here the spot size is very big and here the spot size is very small because of the distance. But when we take two spots on the same leopard, see these two points, these two seems very similar because these two are nearer to each other. Okay, same distance, they appear similar, but the spot of this leopard and this leopard seems different because of only the distance. Okay, so because of the distance, see difference in the distance, the spot is small when compared to distance. Okay, so this is called as scaled orthographic projection. So this is very much helpful to extract the features of front of distance building. So to extract the features from the distance object, the scaled orthographic projection will be very much helpful. Light and shading. In any image, brightness of pixel is based on brightness of surface patch. Suppose the light placed here and that will fall in this direction. Hence, this surface of this object seems very bright when compared to the other side. Here this side seems very dark. Okay, and so based on this light and shading, there are three main causes. The first one is overall intensity of light, and second one is light reflection, and third one is shading. The first one is overall intensity of light. Sometimes the white object in the shadow may be less brighter than black object in the direct sunlight, because the black object is placed under direct sunlight, so it seems very bright when compared to the white object, because white is placed in the shadow. But our eye can easily differentiate this as white object. Okay, because we know the human eye easily capture white object as well as the dark object, right? And second one is different points in scenes may reflect more or less of the light. Okay, so that is based on the texture of object or the markings on the object. Okay, if the texture is like this, okay, so the reflection will be varied, right? The third one is shading. Here the surface patch facing the light are brighter. See, this area is very brighter because this is facing the light when compared to the other side. Okay, this is dark shading. This is called as shading. Okay, so the surface facing the light are brighter than the surface tilted away from the light. Okay, this is called as shading, right? For example, when come to the facial makeup, the dark makeup under the cheekbone, see this area, if we do like this, then the face will looks very thinner. Diffuse reflection. Most of the surface reflect the light by the process of diffuse reflection. That means when light comes here, that will hit the object, then the light will be reflected almost all the directions, so that we will get some diffused image. Okay, so the brightness of diffuse surface does not depend on viewing direction, so it will reflect all the directions. Okay, here most of the clothes, paint, rough wooden surfaces will get the diffuse. There is a difference between specular reflection and diffuse reflection. When come to specular reflection, we will get mirrored image, but diffuse we will not get, because we will get only the blur image. The next one is specular reflection. The mirrored reflection is called as specular reflection. The mirrors are not diffuse. That means in mirror, what you see on the mirror is depends on the direction in which you look at the mirror. Okay, we experienced this a lot. That is, the behavior of perfect mirror is known as specular reflection. So this is the mirrored reflection, that is specular reflection, and this is the diffuse reflection. The next one is specularities. Specularities means the reflection has on some surface of the object. Okay, that means the brushed metal, plastic, wet floor that displays small patches. See, small patches here, this small patches, this seems bright, and here this area seems bright. Okay, so this is called as specularities. Specularity means the reflection on some surface of the object. Okay, these are very easy to identify because they are all small and bright. This image explains the diffuse reflection, shadow, and specularities. Okay, here the specularities on metal spoon on the milk. Okay, see this area here and here. So this is called as specularities, and the bright diffuse surface is bright because it faces the light direction. Okay, see this area, the brighter area faces the light direction, so this seems very bright, and dark diffuse. So these are dark side. Okay, these are dark side because this is away from the light direction, and the shadow, this is shadow. Okay, and here also we are having shadow. The shadow means that does not see the light source, hence it seems very dark. The next one is distance point light source. The main source of illumination outside is sun. Okay, we will get light only from the sun in the daytime, whose rays all travel parallel to one another. Okay, from the sun the light rays will parallel to one another, and that will come to our earth. Okay, and we model this behavior is distance point light source because the light is coming from very distance, and this is most important model for lighting. It is very effective for indoor scenes as well as outdoor scenes, right? And this model, the amount of light is collected by the surface patch. Okay, suppose this is object, the light will be collected from the surface of the patch is depends on angle between the illumination direction and the normal to surface. Okay, so if there is no light, the object looks different. If light falls on the object, then it looks different. In this diagram we can see two objects. First one is A and second one is B. Okay, when come to patch A, the A is tilted away from the light source. Okay, it is tilted away from the light source, the angle is almost 90 degree, and collect less energy, less light energy, because it cuts fewer light rays per unit surface area. See, from this unit surface area it collect only 2 light rays for example. Okay, when come to patch B, this particular object, it is facing the light source, the light angle is almost 0 degree, hence it collects more energy, that is more light energy. The next one is shadow. Shadow is nothing but if the surface is not reached by the light source, then this is called a shadow. See, this area is not reached by the light source, and here this area, these are not reached by the light source, hence this is called as shadow, right? Shadows are rarely uniform black. See, this is also shadow, but this area is not black. Okay, here this shadow are not perfect black, isn't it? Because it gets some light from other light sources. Okay, so when come to outdoor, the most important source is the sky, because sky is very bright. Okay, and when come to indoor, the light will be reflected from other objects, so it will, this area will get some light, right? Okay, this is called as interreflection. Interreflection means the light is reflected on other objects, so it will get some light. Okay, so the shadow is not perfect black. Colors. Colors are part of our everyday life, and without color our life will be boring and dull. And this have a strong effect on scenes, because without color the image will get very dull look, but the color give more information when compared to black and white image. Okay, hence the color on scenes, especially on sight, touch and taste, and also our emotions and overall personality. So everything are depends on only colors. Here light arriving at the eye has different amount of energy at different wavelength. That means all the different colors are having different wavelength. Okay, because of that the animals and birds will identify their food, that is whether the food is ripe or not. When it is ripe, then it is eatable. Okay, so this can be represented by spectral energy density function, that is spectral energy density function. The next one is trichromacy. Trichromacy means mixture of three colors. Okay, normally the red, green and blue color. Okay, so by using these three colors we can create millions of other colors, and the TV and computer displays are using only these three color elements to create all the other different colors, right? And it makes our computer vision algorithms very easier to identify a color. So far we have seen the topic image formation from 4th unit perception, that is the second part, and under this topic we have seen the image without lens, that is the pinhole camera, and the next one is the camera with lens, that is lens system, and a scaled orthographic projection, light and shading and color. In the next class we will see another important topic from perception. Thank you.